Hello, welcome to Operations Management. In this lecture, I will talk about line balancing. Line balancing is the process of assigning tasks to workstations such that each workstation has approximately equal time. So this means it has approximately equal. That doesn't mean it should have exactly. So that's what line balancing is. In this, we are trying to balance the flow of products across different workstations. So this is flow of products are being balanced. Products across various workstations. That is what we are trying to balance. So I will take an example and try to explain the concept. Suppose I have tasks. These are my tasks. So this is task 1 and it takes 0.1 minutes. And then I have, so the product will flow through these tasks. And then I have task 2 which takes 0.7 minutes. And then I have task 3 which takes 1 minute. And then task 4 which takes 0.5 minute. And finally task 5 which takes 0.2 minute, and then the product comes out. So now we have to assign these tasks to workstations. So imagine a workstation is like I have one person doing all the tasks. So the person would do this task first and then move to next task, will do the second task and then move, do the third task and then move and do the fourth task and then move again and do the fifth task. So we are interested in how much time will it take for this person to complete all the tasks. So this will be like this person would complete or the product going in will come out of this system. The time it will take is 0.1 plus 0.7. So the person will work on this first. So that is 0.1 plus 0.7 plus 1 minute plus 0.5 plus 0.2. So this is going to give us 2.5 minutes for one product to come out. So that is 2.5 minutes will be taken for one unit to come out of this system. So that means if we are interested in output rate per day, so this is given by the formula operating time per day, that is how many hours do you operate per day divided by cycle time. So this is our cycle time here. So that's how much we take for 1 unit. So this is the cycle time. So operating time per day, suppose we assume we work 8-hour shift, 8 hour per day. So the output rate for this system would be 8 multiplied by 60 minutes per day. So that is, I'm converting it into minutes, and then the cycle time is 2.5 minutes per unit. So that means this is 480 divided by 2.5. So this is going to give me 192 units per day. So we are able to, if we have one person doing all the work, we would be able to produce 192 units per day. Suppose we take the same problem and assign one person to each of the tasks. So suppose I have the same process. So this takes 0.1 minute and I have products flowing through this, and then I have this 0.7 minutes, and then the third, it takes 1.0 minutes or 1 minute, and then the fourth would take 0.5 minute, and then finally the sixth task will take 0.2 minute. And then we are looking at assigning one person doing each of the tasks. So under these circumstances, the slowest process, as you know, is the bottleneck if we assign each person, and that will be our cycle time. So the slowest process out of these is, this is the one which takes 1 minute. So it takes higher than the others. So mostly the products will be waiting across the system for this person to finish the work. So the output would be 1 minute per unit. That would be our cycle time, not the output. So every 1 minute I will get one product out of this system. So if we wanted to calculate the output rate for this system, output rate, that would be, again, the formula is operating time per day divided by the cycle time. So the cycle time here is 1 minute per unit, and the operating time would be 8-hour shift per day. So output will be 8 multiplied by 60 divided by 1, which is 480 units per day. So if you see, this system will have a maximum of 480 units. This is the maximum this system will produce, because we are assigning more people here, and then here in this it will be the minimum this system can produce, because we are assigning one person. So anywhere between 192 units and 480 units this system will produce. But our goal here, if you see here, we are assigning more people, that means it incurs more cost. Here we are assigning less people, that means we will get less output. So both are not good. So we are trying to balance our line. So to balance our line, one of the things we wanted is how much output we wanted to produce. Like in a company, we will have a demand, so we will think about meeting that demand. That means this output rate is known ahead. So this is mostly, it's the desired output. So that is what, as a manager, you will desire to produce. So the formula gets manipulated to desired output should be equal to operating time per day divided by cycle time. So if my desired output, suppose as a company I decide to produce 240 units, and then I have an operating time which is 480 minutes or 8-hour shift, what would be my cycle time? That's what I'm trying to calculate. So this can be done by just cycle time would be 480 divided by 240, which is 2 minutes per unit. So if I have 2 minutes per unit, now I wanted to determine how many workstations I need, or how many people should I align here. So that is given by the formula n minimum. So this is the number of workstations I need, that is equal to sum of all t divided by the cycle time. So the cycle time from here I will get this as 2 minutes, and the summation of all the time periods for all the tasks is, so if I sum this up, so 0.1 plus 0.7, that is 0.8, plus 1, 1.8, plus 0.5, 2.3, and then 0.2. So this is equal to 0.1 plus 0.7 plus 1 plus 0.5 plus 0.2 divided by 2. So that is 2.5 divided by 2, that is 1.25. So I need 1.25 workstations. I can't place 1.25 workstations, so I will say I need 2 workstations. So that means in this case I will assign 2 people for our tasks. So I will so 2 people I will assign, so that is 2 people, 2 workstations, and each workstation will take 2 minutes. So that is what I am saying. So I need 2 workstations, and at each workstation I will try to assign 2 minutes. So now again I will draw the same diagram and try to assign. So I have 0.1. Now I won't write minutes next to it. So this takes 0.7, and then this takes 1 minute, and then this takes 0.5 minutes, and then this takes 0.2 minutes. So now I have to assign 2 people, and each person can at max work 2 minutes. So maximum they can work 2 minutes. So for the first person I will assign, this is 0.1 plus 0.7 is 0.8 plus 1 is 1.8. I can't assign this because then it becomes 2.3, which crosses 2 minutes. So I will assign these 3 tasks to the first person. So this is 1.8 minutes I assign to the first person, and I can assign second person these 2, which is 0.7 minutes. So that means out of 2 minutes this person works 1.8 minutes. That means 0.2 minutes this person is idle, and this person is idle 1.3 minutes. So the entire system, the idle time would be around this 0.2 plus 1.3, that is 1.5 minutes the system is idle. So out of, so if you see out of 1.5 minutes, out of this is 2 minutes this workstation, or this and this workstation is should take 2 minutes. So out of 4 minutes 1.5 is idle, so that is when you multiply it with 100 it will give you around 37.5%. That's our idle time. So percentage idle time. And if you wanted to calculate the efficiency of the system, efficiency, you have to do 1 minus percent idle time so that is equal to this is 100%, not 100 minus 37.5, this is 62.5. so the efficiency of this system when we assign 2 people would be 62.5% and the idle time would be 37.5%. so this is it's not you are trying to approximately assign the same time. It's not necessary it will turn out to be exactly same, but that's okay as long as you try to achieve the goal of assigning equal times to each of the workstations. So this concludes my introductory lecture on line balancing. Thank you.